Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google based in London. And today I want to talk to you about choreography versus orchestration in serverless microservices. To let you know, this talk, I already have it on Speaker Deck. So if you want the slides, you can get it from Speaker Deck. And I already blogged and tweeted about this topic and also the app that I'm going to talk about in this topic on my Twitter. So feel free to follow me. In terms of questions, I'll try to monitor the chat as we go along. So if you have any questions, please ask in the chat, and I'll try to take breaks and check the chat for questions. All right, so the way this talk is going to go is first, I want to explain what choreography and orchestration is when it comes to microservices. Then I want us to look at the landscape in this area. What do cloud providers provide for choreography and orchestration? Then I want to zoom into orchestration a little bit because choreography, event-driven systems, they've been around for a while, so people know about them. Orchestration is something new. So I want to zoom into that, and I want to talk about Google Cloud's workflows, which is an orchestration service, and what kind of things it provides. And finally, in the last part of the talk, I want to talk about a case study. One of my coworkers, Guillaume Laforge, and myself, we actually worked on an application that we initially wrote in an event-driven way. But then when we discovered orchestration, we said, okay, let's take this app and write it in an orchestrated way. And we did that. And along the way, we learned a lot of things. So I want to talk about this app, what it is, how it worked before, how it worked afterwards, and what lessons we learned. So that's kind of the rough idea about our talk. And as I mentioned, as we go along, feel free to ask questions in the chat. All right, so let's start with choreography and orchestration. Now, let's imagine that you want to build a simple e-commerce app, right? And as you know, in e-commerce apps, people buy things, and then there's usually a kind of like a checkout process as people finish their shopping, right? So in this checkout process, you usually have certain order of things that needs to happen. First, the user makes an order, so there's an order request. Then once you receive the order, you probably need to authorize and charge the credit card to make sure that the user can pay for the request and pay for the order. Then once that's done, you probably need to do certain things for shipping the item. So there's like preparing and shipping the item. And finally, once that's done, you probably want to notify the user that their item is shipped. Now, one way of designing the system is basically have a single monolithic application that does all of that. And that's what we used to do, and it works. But nowadays, we like small microservices, right? So instead of having this single application that does everything, we try to break this application into smaller pieces. And these pieces, they do their bit to get the transaction completed. So for example, if you're on Google Cloud, you might have a front end written on App Engine that receives the order requests. Then that will pass the request to a payment processor. This is a Cloud Run service. A Cloud Run service, by the way, on Google Cloud it's a container. It's a serverless container service, so you can run containers in a serverless way. So this payment processor, let's say it's running on Cloud Run, it does the checks and authorization of credit card. Then you want to pass this to a shipper service, and this can be another service, but this time on Cloud Functions instead of Cloud Run. And Cloud Functions is basically serverless functions on Google Cloud. And then once the item is shipped, maybe you call another service called Notifier that uses, again, Cloud Run to notify the user, right? I mean, obviously, I'm simplifying here because in a real-world system, you have many more things that you need to do. But in a simplified system, this is kind of the services that you would need and the order of things that happen. Now, one way of doing this and this way is basically you have the microservices, and each microservice calls each other directly. So the front end knows about the payment processor and makes that call. The payment processor knows about the shipper and makes that call. This works. And it's better than the monolithic service because you have things broken down into services. But at the same time, it's quite fragile as well, right? Because each service has to know about the next service in the chain. And then if something goes wrong with any of these services, it kind of breaks down the whole chain, basically. So in this model of services calling each other directly, the pros and cons of this model is that, first of all, as I mentioned, it's better than a single monolith, and it's easy to implement. Services just simply call each other, right? But the advantages are probably more. First of all, you have too much coupling between services. So each service has to know about the next service in the chain. Each service can be a single point of failure. So if something fails in the middle, like the whole chain breaks, then you need to think about error handling in these services. So, if you make a call to a service and the service doesn't respond, or the service responds with an error, you need to have that error handling logic in your services. And you need to have probably some kind of timeout logic as well. How long you're going to wait for a service to respond? Or if you get an error, what do? Do you retry the error? If so, how often do you retry? And most importantly, if something fails, like, there is no one checking for the whole transaction. So there's no way to kind of check that the whole transaction is successful. There's no service kind of checking that that transaction is actually successful. So even though this is a simple model, in the end, when you run it in production, you're probably going to have more issues with it because of all the things that I mentioned. Now, how do you get rid of these negatives? What you can do is you can try to do this in an event-driven way. In event-driven model, what you do is instead of services calling each other directly, you have services that respond to messages and emit messages. In this model, you still have the microservices broken down. So you still have the front end, you still have the payment processor, and so on and so forth. But when a request comes in to the front end can simply emit a message to a message broker, to a publish subscribe type of messaging platform, and just say, I received this order. So this message will just say, I received this order with this kind of information. And then this message broker is responsible to route that message to whoever is interested. In this case, the only interested party is the payment processor. So payment processor is the only microservice that actually cares about the fact that there's a new order, right? Then it will receive this message, then it will use that information in that message, and it will authorize and charge the credit card. And once it's done, it will send another message. This time the message will be different. It will just say, I process a payment, and that's it. And then this message goes to the next the next service in the chain, and the shipper will receive that message, and so on and so forth. Now, in this model, as you can see, services don't directly call each other. Services don't know about each other. They only communicate through events. And message broker is the backbone that enables this. So message broker is the thing that sends the messages, and the services, they just simply register their interest in certain kinds of messages. And once they receive a message, they act on it. And once they're done, they will either finish or they will emit another message for someone else to act on if there's some other service that needs to act on it. Now, this is a little bit better, but imagine a more complex transaction, because again, this transaction is a very simplified model, but in a real world, you probably have something like this, where you get a request, and then before you can act on that request, you probably want to check the inventory first. So you need to check your database, see if you have the inventory, and if you are in stock. So if you have the item in stock, then you probably do a certain set of things. But then if you're out of stock, you need to do other things, right? So you need to make a decision up front. And then in your decision diagram, you probably need to do more work as well. Like, so if you're out of stock, for example, you might need to make a call to a third-party provider and get the stock. And then once you process the order, you update your DB again. Then you might want to notify the user, but notifying the user or the customer is usually another third-party call. Maybe you want to use something like SendGrid. If the order is big, maybe you want to notify the sales rep on Slack. So there's all these decision points that you need to make. So imagine designing the system in an event-driven way, right? It is certainly possible. I mean, you can have these services. Again, like, getting messages and emitting messages. But you can see the complexity arising from this, right? You will have multiple types of messages and multiple types of services, and it becomes harder and harder to kind of see what's happening within your system, and harder to kind of debug and walk through this whole transaction. So, and by the way, this event-driven systems, they're also called choreography, because each service is acting like a single independent unit, and they kind of improvise themselves with their messages. So that's why it's called choreography. So this choreography, the pros and cons of this approach is that, first of all, pros is that the services are loosely coupled. They don't know about each other, which is great because that's what you want in a system. Services can be changed independently. They can be scaled independently. You don't need to stop other services from responding to messages. There is really no single point of failure. So if a service in the middle is not working, other services can still respond and emit messages. Now, of course, your whole transaction will still fail, but at least your other services will still continue to function in other contexts. And also, events as a model is very useful. The events are very useful to extend your system beyond what you have today. So if you have a current system using events, if you want to add a new service, it's very easy to add that service, because all you need to do is add the service and configure what kind of services and what kind of messages that service needs to respond to, and that's it, really. So it becomes much easier to extend your system. Now, on the other hand, the cons of the choreography is that, and I mentioned this already, with event-driven systems, it's really difficult to monitor the whole system. You have all these events flying around, and it becomes harder to figure out when something fails. So if a transaction fails, you need to basically look at all your services, you need to look at all the logs and kind of try to figure out where that happened. So it's not straightforward anymore. And then this whole thing about errors and retries and timeouts that we talked about with services calling each other directly, you still have that problem, right? So if a service, let's say a service receives a message and it cannot process that message, some error happens. What do you do in that case? How do you retry? And then, who detects that? All these are still quite problematic. And I think one of the things about event-driven systems that's kind of missing is that, when we look at this diagram, the business logic, it's very clear what needs to happen. You receive an order. If there's stock, you do certain things. If there's no stock, you do something else. So this business logic is very clear. It's a flow chart. But trying to capture this in an event-driven system is very difficult. You can make this happen in an event-driven system, but you cannot point to a flow chart, or you cannot point to a service in your event-driven system that captures this business logic. So you're kind of losing this information basically within your event-driven system. So that's what I mean by business flow is not captured explicitly somewhere. And also, the biggest problem with event-driven systems is that you still have this problem of, who ensures that the whole transaction is successful. So each service itself, it can receive events and it can respond to events, and they can kind of make sure their own piece is kind of complete and successful. But no one is actually looking at the whole system. No one is looking at all services and make sure that the whole transaction is completed. And so that's still a problem with choreography. So that takes us to orchestration. Orchestration is another way of organizing your microservices. And the way it works is that you still have individual microservices. So you still have front-end, payment processor, shipper, and so on and so forth. But instead of them calling each other, or instead of them emitting messages, you have a central orchestrator service that directs how things flow. So in this model, when a request comes in, it still goes to the front end. And then from the front end, you kickstart an orchestrator, basically. You tell the orchestrator, I received a new request. Can you handle this? and an orchestrator calls the services that it needs to call in the order that they need to be called with the parameters that it needs to be called. So orchestrator will call the payment processor first and make sure that it works. Then it will call the shipper and it will call the notifier, so on and so forth. The good thing about this model is that there's a central place, the orchestrator, that's directing the whole thing. And also, the orchestrator can monitor these calls. So when the orchestrator makes a call to the payment processor, it can actually see if there's an error and it can retry the call. And the order is also captured. The orchestrator is the one making the call, so you can kind of capture the order of flow in an orchestrator. So the pros and cons of this approach is that, first of all, business flow can be captured centrally. So you can, in the orchestrator, you can specify how things are supposed to work, and you can source control that actually. And I'm going to talk about this in more detail as we talk about Google Cloud's workflows. Each step that your orchestrator makes can be monitored. So if something goes wrong, you will see it really easily with orchestrator because it is the one making the calls. If you need to apply for any kind of error or retry or timeout kind of policy in your microservices, you can do that in the orchestrator. So you can set these policies in the orchestrator, and orchestrator will apply these policies in a consistent way without you having to implement them in each microservice. And this is really good because you don't have to redo everything in each microservice. And since you're making calls from orchestrator to the microservices, you can stay in simple HTTP calls, simple REST-based calls. And this is basically good for simplicity because in event-driven systems, you're dealing with events, and events, there's the event payload, and you are probably dealing with multiple types of events. So there's all that logic of reading the events, parsing the events, and then emitting the events. All that logic has to live within your microservices. Whereas in orchestration, your microservices can be just respond to simple REST calls, and it doesn't need to, the microservices, they don't need to have the event parsing logic, and that kind of simplifies your microservices a little bit. And I will also show this when I show the demo application later. And the good news is that your services are still independent. They still are deployed independently. They can still be scaled independently. So you don't have to put them all together in a single monolith. They can all act independently, but you have the central orchestrator orchestrating things, which is the good thing. Now, on the other hand, in terms of disadvantages, a new orchestrator, it's a new service that you need to understand and you need to worry about, right? So that's, it's a given. It's another service in your system that you need to worry about. And it can be a single point of failure. I mean, hopefully you're using an orchestrator that's, highly available and resilient and redundant and stuff like that. But at the end of the day, an orchestrator is another service that can fail. So you need to keep that in mind as you're using orchestrators. And since you are relying on REST calls, your services, they tend to be more tightly coupled when you're using an orchestrator because you don't have this flexibility of event-driven systems that comes with it. I mean, event-driven systems, they're more complicated, but they're more flexible. So you kind of lose that flexibility a little bit when you convert from event-driven to REST-based microservices. All right, so at this point, you might be wondering, okay, what do I use? Do I go with choreography or do I go with an orchestrated system? And the answer is, it depends, right? Like, I mean, in software engineering, everything is kind of like this. Everything, it depends on your use case. It depends on what you're trying to do. But as a general guideline, I feel like choreography, in other words, event-driven systems, are useful when you have services that are not closely related, right? So if you have services doing distinct things in your system and they don't really need to communicate with each other, they just need to do their work and just move on, then choreography or event-driven is usually better. And event-driven systems are also useful when you have services that can exist in different domains, basically. So, for example, let's say you have a notification service. That notification service can be in a checkout process, like checkout system, but it can also be part of some other system. And when you design this microservice as an event-driven microservice, then it's easy to use it in one context and also another context, right? You don't need to rewrite much. You just need to connect the service with the message broker. So if you're thinking of reusing services in different contexts, then I think event-driven is usually a better solution. On the other hand, orchestration is useful for use cases where you have a business logic, and the business logic is well-defined, so much so that you can define it in a flowchart. And if you can describe that in a flowchart, then it becomes a good candidate for orchestration. Because if it's a flowchart and that flowchart doesn't really change, and you want to make sure that the flowchart executes in that way, then maybe you should start thinking about orchestration. Also, in cases where you have services that are closely related and they usually go together, then there is not much point making them event-driven. Because if you have 2 services or 3 services that usually go together in certain order, then you might as well either call them directly, because they always call each other in that order, or better, use an orchestrator to make that call, right? And finally, if you don't want to deal with the complexity of event-driven systems and all the event parsing and event emitting, all that kind of stuff, and you want to stay in pure HTTP REST-based solutions, then maybe orchestration is a good solution. So it really depends on where you are with your system and what you want to do. But hopefully these are general guidelines to give you an idea on when orchestration is useful and when choreography is useful. And you can also take a hybrid approach, right? So you can, for example, have a bounded context. You can maybe have a system where you have services that are related, and you want to make those services orchestrated. So you create like an orchestrated bounded context for those services. But maybe at the end of the bounded context, you want to notify another service that you finish your checkout process, for example. For that, you might want to use events, right? So you have the checkout process orchestrated, and in the end, maybe you want to emit a message and say, okay, I'm done with checkout. And then that goes to another bounded context, and that does some other orchestration. So you can use a hybrid approach where you have orchestration in the middle, and then these bounded contexts, they communicate with each other with event-driven kind of way. All right, so that covers the orchestration and choreography part of the talk. Now I want to look at the landscape, and I think so far there are no questions, but if there is, feel free to ask in the chat. But I want to look at the landscape now, and let's say you want to build an event-driven system or an orchestrated system. What kind of solutions exist out there? Let's take a look at that, and then we'll look at orchestration after that. Now, event-driven or choreography has been around for a long time, and no matter what cloud you're running in, AWS, Azure, or Google Cloud, there is more than one solution for event-driven systems. So, for example, on AWS, there's EventBridge that aims to be the eventing platform on AWS, among with SQS or SNS and other things on Amazon. On Azure, I hear a lot about Event Grid and Event Hubs and things like that. On Google Cloud, PubSub is the main message-driven service on Google Cloud, but we also have something new called EventArc that's coming up as kind of the new event hub on Google Cloud. Of course, if you're in open source, there's Kafka and RabbitMQ and other solutions as well. So as you can see, there's a lot of solutions out there already with event-driven systems. And I won't get into details of these because I feel like people already understand these systems, or they at least understand what an event-driven system involves. And the concepts are very similar between different products. But just know that there's a lot of solution out there. Now, in terms of orchestration, there's less solution and less products, and it's also something newer when it comes to the technology. So on AWS, there's step functions to basically call functions in the order that you want. On Azure, you have logic hubs, which is again ordering the ordering the services, but also applying some kind of logic on top of them. On Google Cloud, there's couple of solutions. One is workflows. Workflows, it's about orchestrating services. So if you have cloud functions, if you have Cloud Run or App Engine, and you want to orchestrate the calling of those services, then Workflows is great for that. Then there's also something called Cloud Composer, which is also about orchestration, but it's based on Apache Airflow, the open source project, and it's more about data than services itself. So if you have data that you want to orchestrate, then Cloud Composer is a good solution. But if you have services that you want to orchestrate, then Workflows is the solution. And of course, there's open source solutions like Apache Airflow, and I'm sure there are others as well for orchestration. There's also a serverless specification that's coming up. This is from CNCF, and it basically tries to create an open source workflow specification about how to define workflows and how to execute workflows. Try to bring some kind of standardization around that, so that going forward, hopefully there will be one standard that all the different tools and services use. So right now, I don't think any of the products in any cloud implements this specification yet, because it's not complete. But it's something to keep an eye out, because at some point I think it will be something to watch out for. All right, so now let's look into orchestration in more detail, and more specifically, I'm going to talk about Google Cloud's workflows. The reason is because I know Google Cloud and I know workflows, so that's why I want to deep dive into that. But the concepts that I'm talking about here, they probably apply to other services as well. So I haven't looked in detail, but I'm pretty sure on AWS or Azure, there are orchestration solutions. They also probably have similar concepts. So my goal here is just to show you what's possible with these orchestration services, so that you get an idea on what kind of things you can expect from them. So we'll go through this, and then once we understand what workflow does, then I want to show you an app, and I want to show you how we transform that app from event-driven to orchestrated app. All right, so what is Workflows? Workflows, it's a serverless service that helps you to orchestrate and integrate a bunch of different things, basically. It helps you to orchestrate serverless compute services. For example, if you have Google Cloud Functions, if you have Google Cloud Run services, if you have App Engine applications, these are all HTTP-based services that you can deploy on Google Cloud, and they run differently because functions, they run as functions, Cloud Run runs as containers, App Engine is applications. But at the end of the day, they're all HTTP-based services, and you can use workflows to call them in the order that you want, right? But workflows is more than just these services. You can also call any Google APIs. So any Google APIs on Google Cloud, or any generic Google APIs, such as Gmail or Maps or anything like that. Anything that has HTTP, public HTTP, you can use workflows to orchestrate. And it even supports external APIs. So for example, if you want to use SendGrid to send emails, or if you want to use the Slack API, things like that, you can still use workflows. I think this is very important, and it's very useful, because in workflows, you usually call a service, and then you take the output, and then maybe you call another internal service, and then maybe after that you want to call an external service. So it's never just one thing. It's usually a mix of different things, and workflows really allows you to be able to do that in a consistent way. So you might wonder at this point, like, how do you define these workflows, and how do you actually call services? And the way you define is either YAML or JSON syntax. And here I'm showing the YAML syntax. And in this YAML syntax, you have this notion of steps. So you define a step, and then you define how you call that step. And then you define what goes into the step and what comes out of the step. Basically, that's the idea. For example, in this case, let's go back to our previous example. We have the payment processor, we have the shipper, we have the notifier. They're running on different places, Cloud Run, Cloud Functions, and you want to call them from workflows. So what you do is you create steps for them. So you have process payment step, you have ship items step, you have notify user step. Then you specify what gets passed into this step. So in the first step, we are passing in the payment details. That's the parameter. Then we specify how workflows should call this service. So the call is HTTP post. And then we are passing in the URL. URL is the URL of the Cloud Run service. And then we specify the body of this HTTP post. So the body is basically the payment details that we received, right? So that's how workflow calls the service. And then the result, you can capture the result. So we capture the result as process result. We call it, you can call it whatever you want, but we call it process result in this case. And the good thing is that once you have this result, you can process that in workflows. So you can transform this result. You can pick the parts of that result if you like, and you can pass that result to the next step. So in the next step, we have ship items. We are again calling it with HTTP post and passing in the URL. And the input is from the previous result. So we look at the process result, and the body of that becomes the input to ship items, and so on and so forth. So that's the main idea with workflow. So you define your business logic this way in the YAML. As I mentioned, you have the steps that you define. So you can define steps like sequence steps like this. You can do things like serverless pause. So for example, let's say from the shipper, before you actually notify the user, you want workflows to wait for a certain time. You can add like a wait here, and workflows will wait and then call your service. And then it also has this variable passing and JSON parsing. So you can pass variables within steps, and then once you receive the results, you can parse those results. So it's not simply just passing the variables, but you can also parse these results. So there's some syntax for that as well that we can take a look. Now, once you have these steps, you can also apply errors and retries to these steps. For example, let's say you make a call to the payment processor, but there's something wrong. You can specify an error policy, and you can say, if something fails, I want to try maximum 5 times. So workflows will call it 5 times, and you can also specify how it will call. You can say, I want to call it in an exponentially back off kind of way, and workflows will, if something fails, it will call 5 times in an exponentially back off kind of way. This is very useful because now you don't need to apply this logic in your services themselves. You let workflows do that for you. You can also route the results depending on whether the result is successful or not. So let's say you call the shipper from workflows, but shipper failed with HTTP 400 or something like that. You can take that error and you can send it to another service. Or if the shipment was successful, you get 200. You can take that and send it to another service. Again, this is very useful because you don't need to do this in your code. You can let workflows direct your logic to the right place. You also have conditional logics. So let's say you read the inventory in this case, and you want to check if you have stock or not. So workflows gives you syntax to check the result of reading the inventory and checking whether it's basically more than a certain amount, for example. And if that's the case, you can call some other branch. If not, then you can call the other branch. So you can do all of this in workflows YAML instead of the code. And you have access to third-party calls, right? So here, for example, we are making a call to the third-party supplier. So it doesn't have to be within your system. You can make calls to any public HTTP kind of endpoint. And finally, the last 2 features I want to point out is that you can create sub-workflows. So let's say you have a workflow that you want to call in multiple different places. You can capture that as a sub-workflow. It's kind of like a method call in code. Instead of that, you do a sub-workflow in YAML, and then you can reuse that sub-workflow in multiple places. And we also have connectors to Google Cloud Services. As I mentioned, you can make HTTP calls to any kind of service, including Google Cloud Services. But we also have these connectors that makes it even easier. So instead of creating the HTTP call within YAML with the right parameters and everything, you can use these connectors. That's basically an easier way to make these calls to these services. All right, and to deploy a workflow, you can do it from command line using gcloud. So you can just say, you define your workflow in a YAML and just say, deploy this workflow. So this just deploys the workflow in the cloud. Then once it's deployed, you can execute it using workflows execute. And then you can see the result with execution described. and then this will give you the output of the workflow, basically. So all of this is command line, but you can also do this from UI. So as you can see here, I'm in Google Cloud Console, and here I have the source YAML. So this is my business logic definition in YAML. And then I get a visualization of how that looks like. So for example, here I'm doing a switch, and when I get a certain event type, I call either this branch or I call the other branch if I have another event type. And I have a third branch that says this event is not supported. So I can easily see from YAML what my business logic looks like. And I can also execute and look at the output from this UI. All right, so that was a really quick summary of workflows. Now I want to talk about our application and kind of bring together all these concepts that we talked about and how they help our application to be more resilient using orchestration. So this application, we called it Pic-a-daily. You might be wondering, what does Pic-a-daily means? So this app it's a picture sharing app. It's an image sharing application that we initially wrote to showcase Google Cloud serverless technologies to a customer in London. And for those of you who know London, there's an area of London called Piccadilly. So we combined the Piccadilly from London and the pictures from our application, and we called it Pic-a-daily, basically. And what this app does is that it gives you an ability to upload pictures for users, so you can upload pictures, and the app analyzes these pictures, and it does a couple of things. First, it picks up the labels from these pictures. So you can see that this picture, we have the labels of dish, food, cuisine. This is a picture from Paris, the landmark, sky, monument. So all of these labels are extracted automatically using Vision API. So, it's a machine learning API on Google Cloud to extract labels from pictures. So the user uploads the pictures, these are extracted, and you can also see that there's a border around the picture, and this border is actually also automatically generated. So using Vision API, we detect that the dominant colors in the picture, and we pick those colors and use it in the border, right? So that's the app in a nutshell. We also have a collage part of the app where we combine multiple images into a collage of pictures. So we built this app just to show how Google Cloud serverless technologies work. And actually, I should have the app up and running. Let me see if I can show it. So yeah, you can see my pictures here. You can see if I click on collage. Let's see if this works. So you can see a collage of the pictures, 4 pictures. You can upload any picture if you like. But basically, it's a simple app just to show the Google Cloud serverless technologies. And I should also mention that there's the code of this app that I'm going to share. The link is all open source. We talk about what the app is about, and we also have labs. So if I go to this link, and I'm going to share this lab as well. We have 6 labs that shows you how to build this app. So if you want to build this app yourself, you can do it as well. But let's just go through this app architecture first. So the way we built it first. And this is how the initial architecture of the app looks like. And let me just go through this quickly, and then we'll talk about what were some things that wasn't great about this initial architecture. So the initial architecture of the application was that you have the users uploading the pictures through a front end. This front end, it runs on App Engine. And then App Engine, when it receives the picture, it uploads to Google Cloud Storage in a bucket in Google Cloud Storage. And once the picture is uploaded here, then a number of events get fired. Now, the first event goes to this image analysis function. This is a cloud function that analyzes the image using Vision API and gets all the information about the label of the image and the colors of the image and things like that. And it saves it into Google Cloud Firestore, which is a NoSQL database. Now, the second event that gets fired is to a Cloud Run service called Thumbnail service. This service, it takes the image and makes a small version of the image So it resizes the image and saves that information to the Firestore as well. And as you can see, it goes through, the event goes through PubSub because Cloud Run doesn't support native cloud storage events. So that's why we had to go through PubSub. Then we have another service called Collage Service that gets triggered by Cloud Scheduler. And on a schedule, it will go and fetch the 4 latest images, and it will create a collage of those images and save it to the bucket. So this is like another event. And finally, we have an image garbage collection service. And this service, it only responds to deletion events. And what it does is that when someone deletes an image, it will go and delete the thumbnail of the image, so the small version of the image, and it will also delete the metadata of the image from the database as well. So it cleans up the data of the image, basically. And this event is done through EventArc. EventArc, it's a new way of receiving events on Google Cloud, so we used EventArc in this case. So as you can see, the architecture is not super complicated. We only have a few services, but there's already a bunch of things happening. We have a bunch of events that are being fired, and all of these events are different kinds of events. In Cloud Functions, it's direct events from cloud storage. In Thumbnail Service, it's through PubSub messages. In Garbage Collection Service, it's through EventArc. So all our services, they're getting events in different ways. They are loosely coupled, great, but at the same time, we don't capture the logic of the business logic per se of this application anywhere. And when something doesn't work, it was already getting hard for us to figure out where. So every time something didn't work, we had to basically go through all the services and look at the logs and all kind of stuff. So even though things worked, it wasn't ideal. And that's when we started looking into how we can use workflows to actually make this more streamlined. And what we did is basically, I should mention that I already mentioned there's 3 different kinds of events, right? And when you look at the code, the Cloud Functions would get the events this way, and this is not JS code. The Cloud Run will get the PubSub messages this way, which is base64 encoded, and it will parse it to get the file event. And then the image garbage collection service will get a cloud event from EventArc that has an audit log, and we would parse that differently as well. So you can see, like, we were already dealing with 3 different event types, and this kind of made things more complicated. So we rewrote the app in workflows, and after workflows, this is a new architecture of the app. When you look at this architecture, you might think, oh, this looks more complicated than before. It does look more complicated, but it's not, because I put the workflows logic here as well. But actually, all this workflows logic, these flow charts, they are part of workflow. So it's actually one service, and the rest are other services. So it's actually simpler. But in this logic, what we are doing is that when user uploads the image to front end, again, we have the App Engine front end, the same App Engine. It goes to the bucket, and the bucket triggers the file creation or deletion event. We have a single Cloud Function that receives that event, and then it says to workflow, can you start this workflow, basically, to handle this image creation or deletion? And workflow receives this, and it says, okay, let me check the event type. So workflow checks the event type. If it's a near file, it goes to this branch. If it's not, if it's a deletion, it goes to this branch. Then it basically does a series of events, right? And these events, they either happen within workflow, or they happen by calling other services. So in this case, for example, we have an image analysis step that does a call to Vision API directly, right? It makes call to Vision API and receives the data from Vision API. We got rid of the Cloud Function to do that because workflows can call the Vision API directly. Then it gets the data, and then it calls another Cloud Function to transform the data. Then we do a safety check for the image. Then we store the metadata to the Cloud Firestore. Again, this is done in workflows. And then we have the thumbnail call and collage call. These are the 2 Cloud Run services that we had before, but we just simply call them from workflows, right? And they do their own work. So all of this is basically very streamlined. And if it's a picture deletion, then workflows deletes the image, and it deletes the Firestore entry as well. So we don't need to create any new services for that. It's done automatically for us. And if you look at the actual workflow, so let's go back to Google Cloud, and you can see I have my workflows defined here. I call it Pic-a-daily workflows. And then you can see the execution of my workflows. But if you look at the source, you will see that I'm defining my YAML. So this is my workflow. It receives some arguments from the Google Cloud function. And depending on the event type, it does certain things. And you can, I mean, we don't have to go through this in detail. It's on GitHub if you want to take a look. But the flow is very clear. Like looking at this, I can clearly see what happens. I can see the logs here. And actually, if we look at the executions, we can see whether the executions worked or not. So for example, if I go back to my application and upload a new picture, let's just upload a picture of myself. Now this will trigger the event, and it will go to workflows, and now workflows is working through the event. So let me refresh this. It will take a minute or two so you can see that the image is processed. And if we go back to our workflows and do a refresh here, I can see that this was just triggered now, and I can see the execution. So this was the input to my execution. This is the output, and the output in this case is each service HTTP code. So collage service ended with 204, image analysis store metadata with 200, and timeline with 204. So it becomes very clear how things worked or not work and things like that. All right, so that's how we kind of refactor our application, and I have a blog post on this explaining in more detail. So if you want to read more, feel free to check out my blog post on my website. So the lessons learned in this case is that converting from event-driven systems to orchestrated system, in our case, was very refreshing. We went from 3 different event types and handling those events in different ways to a simple REST calls. And because of this, we made our microservices much simpler because we don't have to deal with event parsing and event generation. Our code became less, no event parsing. We got rid of image analysis function. We got rid of garbage collection functions and things like that because we could do all of these from workflows itself. There's just simple HTTP calls. We had less setup because we are not using PubSub anymore. We are not using Cloud Scheduler anymore. We are not using Event Arc anymore. We don't have to set them up. We don't have to hook things up. Instead, we just set up workflows. So instead of dealing with 3 different systems, now we're dealing with 1 system to do everything in a consistent way. And error handling became really easy. I mean, our error handling is basically just let workflows call the function, and if something fails, workflows will let us know. We didn't apply any kind of error handling logic yet in workflows, but it's very easy to do now. We can globally apply it in workflows. And on the other hand, in terms of drawbacks of workflows, it's a new service, right? It's a new orchestration service with its things and quirks and limited things. So because of that, we had to basically figure out like how it works and kind of learn about this new service. But this is true with anything you want to use. Anytime you want to use new technology, you have this learning curve that you have to kind of spend time on and learn. The other thing is that we always had to have this question in our minds between code versus YAML. Because before we were doing things in code, in a cloud function or cloud run. Now, once we get rid of the cloud function, we took the code and do it in YAML in workflows. So that's a question, right? Because code is testable and you can write unit tests for the code, whereas when it's YAML, it's not so testable. So we were always wondering, should we do this in code or should we do this in YAML? And once we decided with YAML, how do you do it actually? Because it's not as straightforward as writing the code, right? So you have to figure that out all the time. And also the YAML is a single YAML file right now. Right now, Workflows doesn't support multiple YAML files. So a single YAML file can get quite big. So these are things that you have to keep in mind. I mentioned this already, debugging, testing, and logging right now, it's limited in Workflows. It's not like code. So because of that, it's a little bit more difficult to work within the YAML. And there's no IDE support. So for example, the YAML file, you can open an IDE, but there's no kind of way of checking the syntax or anything like that. It's coming, but it's not there yet, so it makes it more difficult to test and debug. Workflows right now, it doesn't support parallelism, so you have to do things in steps, although we are adding parallel tests soon. But because of that, you lose a parallelism. So at some point, we could parallelize our tests, but we couldn't in this case, so we had to do them one by one. But it's quite fast, so things happen really fast. So that's the good news, but it's not parallel. And finally, you also lose the flexibility of eventing, right? Because eventing gives you total flexibility on how you respond to events, and how do you read events, and how do you respond to events. And once you get rid of that and put your services in an orchestration, you lose that flexibility. But you gain this structure or workflows. So it's a trade-off that you have to keep in mind. Okay, I think I'm almost out of time with 4 minutes left. So I want to give you some links. So if you want to learn more about cloud workflows, it's cloud.google.com/workflows. If you want to do our workshop, we have it at this link. It has 6 labs. The first 5 labs is the event-driven part of the app. So if you want to build the app in an event-driven way, you can follow them step by step. If you want to do the workflows way, then that's lab 6. And in there, we basically just do the workflows part. So feel free to check it out. And if you have any issues, open an issue on GitHub, or feel free to reach out to me as well, because we're always interested in hearing from you. And if you want to take a look at the code, it's on GitHub. By the way, our workshop is multi-language. So it's written in Node.js, C#, Go, and others. But we are always looking for more contributors. So if you want to contribute to a language that's not written for a certain service, feel free to check it out and let us know. And this is my Twitter for any questions after the talk. And then if you want to get the slides, it's on speaker deck. So I will just pause here for now. Let me just double check if there's any questions. I don't think there's any questions in the chat, but you can always reach out to me after the talk on Twitter. Thanks for listening. Hopefully this was useful to you. And if you have any feedback about the code or the talk or anything, please let me know. I will be very happy to hear from you. Thanks very much.